The third theorem under probability is Bayes theorem. First we have addition theorem, second multiplication theorem, followed by the third one is Bayes theorem. Addition theorem says that it's a kind of a union. That means at least one of the two events, at least one of the n events, at least, then you can identify that the problem belongs to an addition theorem. And if something is going to be happen simultaneously, one after the another one immediately, then that kind of problem belongs to the multiplication theorem. And moving on to the last topic of that means Bayes theorem, see the situation over here. I'll be saying you two statements, the same situation, but in two different statements. First one is, let us take an example of, there are three bags are there, and in each bag there are different colored balls are there. My first statement is, what is the probability of drawing a red ball from the third bag? What is the probability of getting a red ball from the third bag? That is a straightforward question. So that is called as a normal straightforward probability problem. Now the second case is by blindfold. That means by closing my eyes, I have just picked up one ball from one bag. I don't know what is that bag. Now by opening my eyes, I found that the ball is a red color. Now my question is, what is the probability that this ball is from a particular bag? Either it is from a first bag or second bag or third bag. Here, what in the second situation, what has happened? Already the ball has picked up. Now I'm asking, from where does this ball has come? In the first situation, I am directly saying that pick up that particular ball from a particular bag. That is the difference between the first and the second situations. So first one is called as direct probability, and the second one is inverse probability. Coming from back to the front is called as inverse probability, and inverse probability is called as Bayes theorem. Okay, now with the same example, let us see this statement. I'll explain this statement. If an event A can only occur in conjunction with one of the n mutually exclusive and exhaustive events, E1, E2 up to En, and if A actually happens, then the probability that it was preceded by a particular event is given by P of Ei by A is equal to P of E1 into P of A by E1 whole divided by summation of P of Ei into P of A by Ei. What does this mean? What is this explanation? Now, here A is called as a red ball for us, and E1 to En are called as bags here. All E1, E2, E3 up to En, we have all different bags, and out of which A actually happens. A actually happens means what? Drawing our red ball. That means if we are already picked up a ball from the bag, now what is the probability that it is preceded by that particular event? Now, if you wanted to draw one ball from a particular bag, even the bag is also having a probability, right? Now, see this formula, P of E3 by A. This is E3 by A is called as conditional probability. What is conditional probability? A is already happened. Means what? I already picked up my ball from the bag. Now, what is the probability that this ball is from that particular bag? Which particular? Third bag here. Now, what is the formula of probability? Basic formula of probability is favorable number of cases by total number of exhaustive cases. Now, let us suppose I'm having three bags with me. So now, if I want to pick up a ball from that particular bag, first I need to go to the bag. That means each and every bag also consists some probability, and picking up the ball from that particular bag also includes some probability. Now let us see the total number of exhaustive cases first. Now P of E1 means probability of selecting first bag, P of E2 probability of selecting second bag, P of E3 is probability of selecting third bag. Now I already said you that all the bags are containing red balls now. So what is the probability of getting a red ball from bag 1? What is the probability of getting a red ball from bag 2? And what is the probability of getting a red ball from bag 3? That means we have a probability for both selection of bag and selection of red ball from the particular bag. So then only I can get a particular ball from a bag, right? So this is exhaustive cases. Now, favorable number of cases means what? Out of exhaustive cases, only one of the event will be our favorable cases. Now we are having 3 bags as the denominator, out of which I am asking what is the probability it is from the third bag. So out of these 3, our third part will be our numerator. See the generalized formula, numerator and denominator both are same, but in the denominator we have only summation. Summation means out of n events, I am selecting one event, that is our favorable number of cases. If it is from bag 1, our numerator will be P of E1 into P of A by E1. If it is from bag 2, we'll be having P of E2 into P of A by E2, but the denominator keep constant. Okay. And this is explanation of Bayes theorem.